Bismillahirrahmanirrahim. Assalamualaikum. In this video, I'm going to continue on DOE analysis, or we are going to do ANOVA test. Okay, refer to this example. Okay, this is the previous example. Okay, we already I already show you how we can calculate all the sum of square for this example, and then we want to proceed with the ANOVA test. Okay, so there is only one factor, which is the machine, and there are two levels of the machine, which is the type of machine, USA and Japan. Okay, so A equal to 2 and equal to 3, which is the replicate, and total observation is equal to 6. So in order to do the ANOVA test, it's more easy if we represent all the statistics that we need to use for the ANOVA test in a table. So we summarize the sum of square, and then the respected degree of freedom, and then the mean square, and also the F ratio test. Okay, so for the machine, okay, sum of square of the factor, and then sum of square of error, and then sum of square of the total, and then this is the degree of freedom of the factor, error, and the total. And then from that we can compute the mean square, whereby the sum of square divided by its degree of freedom, we obtain the mean square. Okay, and then from that we can calculate the factor, F naught, which is the ratio of the mean square factor divided by mean square error. So mean square factor divided by the mean square error, we obtain 150. So this is the statistic that we are going to compare with our control limit. In the hypothesis testing chapter, we call it critical value. So alpha here we take 0.05, and then V1 is 1, and then V2 is 4. Okay, so we obtain the F value 7.71. So here we can use the statistical table. Okay, so if you refer to the ebook that I already gave previously, so there are, in appendix we have the statistic table for the F distribution. So it's quite different from the Modox table. Okay, but the value is of course similar. Okay, so in this one I show an example of the alpha is equal to 0.01, and then on the horizontal here value for the V1, and then vertical value here for the V2. And then for, okay, let's say refer to example just now. Okay, V1 is 1, and then V4, sorry, this one is 0.05. Okay, so 1, 4. Okay, let's say the value is 1, and then the V1 is 1, and then V2 is 4. So 21.2. So, but this one is for the alpha equal to 0.01. Okay, so of course it's not the same with this value is 7.71. Okay, and then you also can use the Modox table, statistical table, table 9. Okay, so this one also I already give to you. So just a recall, okay, because I already show you this one. Okay, so for Modox table, so the same, it will give the F value according to different alpha, but now it put in the same table. Okay, for the combination of V1, V2, there are 4 values. So let's see for V1, 1, and then V2, 4. Here we have 4 values. So it is ordered according to the different alpha. For the first value is for alpha equal to 0.05, and the second value is 0.025, and then the last one is 0.01, which is the bracket is for the value of 0.025. Okay, so for example V1, V2, okay, so if it is 0.05, okay, so it is for the first value, so it is 7.71. okay, for alpha 0.05. okay, so this is the value here, 7.71. So this one can refer to the value table just now. Okay, and then we compare the value of the F ratio here with the control limit. So the F ratio is 150 and then the control limit value is 7.71. Means that this is greater than the control limit. So we know that previously the principle, if the F naught is greater than the control limit, we will reject the null hypothesis. Means that we can conclude there is a significant effect on the process capability. Okay, means that the factor give significant effect on the observation, which is the response. Okay, in this case is the process capability. So if you want to draw the F distribution, so the critical value or the control limit is 7.71 and then the F value is 150. So this is alpha of 0.05. Okay, the area here is alpha. Okay, and then the value here for F naught is 150. So we know that it starts from 0 because it is all positive value for the F value. So start from 0 and then getting larger. So 150 of course around after 7.71. Okay, so it is included in the rejection region. So that is why we reject the null hypothesis. Okay, so that is how we make a decision and the conclusion for the ANOVA test. Okay, refer to the second example. Okay, this is refer to the table 9. Okay, second example. So whereby the effect of the level for each level is 0, and then just like the previous example just now, we put in table. Okay, the sum of square, degree of freedom, mean square, and then we compute the ratio, F ratio. Okay, then we get the F ratio is equal to 0 because here the mean square is 0 for the factor. So means that here when we compare with the control limit, it is less than the control limit value. So we cannot reject the null hypothesis. So the conclusion is the factor do not have significant effect on the process capability. Okay, I want you for this week, you try yourself, okay, by using this example 3 data. Okay, so you try your own. So this example actually already done for you. Okay, so there are given already all the value and also the conclusion, but now I change a little bit on the data. Okay, so instead of taking 6 replicate here, okay, for example 3, okay, I add another 1 replicate for each level. Okay, so this is the 7. Okay, so it is 1, 2, 3, 4, 5, 6, 7. Okay, so I add another 1 for respected percentage hardwood concentration. So 12 is for 5%, 20 is for the 10%, 20 again for the 15%, and this one is for the 20%. So should be it is put in here. Okay, so but the space is not enough. So you study first the example, okay, the original data, which is this one. Okay, and then you go through first and then you try your own by changing the data. Okay, and then you submit, okay, in the Google Classroom. Okay, try please try, because if you don't practice, then you do not know whether you really understand the procedure or the step in the ANOVA test. Okay, bye bye. Assalamualaikum.